So you mentioned that a lot of companies sometimes get forced, like they have no choice but to do this. My follow-up question here is like, you laid out such like a logical case for like the dilemma here that people face. So why do companies opt into this type of like locked in vendor spend typically?
Lack of opportunity of alternatives, right? So AWS and Google and Azure are slightly different ecosystems, right? They have similar and competing services, but they're not exactly the same. The APIs for those services aren't the same. The way you work with them isn't the same. So you have specialization within your team. So an engineer probably knows how to work with one, maybe two clouds, but certainly is not fluid across all clouds. So if you build a center of competency in your engineering team for a single cloud, you're locked in, you're going to stay there, right? So now that cloud has you kind of trapped. So you don't have a lot of optionality to price between vendors. So going into a reservation seems more logical. And honestly, it's the easy path. Like if you're just doing financial analysis and you're saying, okay, well, if we commit for two, our business has been running this way for 3 years. If we commit for 2 years, we're going to get this 40%. It solves my pain point today. Let's just do it and get it over with. But you're really putting a small band-aid on a very large wound.
What are the alternative options beyond just saying we have to commit X amount to AWS or Azure or Google or whoever for 3 years? What's the alternative options for folks that they should strategically consider?
Yeah, so when I was doing the analysis on this and I kind of stepped back and looked at the word, like what would the utopia look like? We had to kind of make some fundamental assumptions. But when you rent a computer and you install a whole bunch of software on it, you've essentially these things are called virtual machines, right? Because they're exactly like computers. They've got all of the peripherals associated with a computer, and you manage them like you would your PC. You install software, and then if it needs a security patch, you do a security patch on that software. Well, it turns out that's not a very good way to deploy software at scale. So the world is moving to and has moved in large part to these things called containers. You may have heard the term Docker container in the past. These containers are really small footprints that embed all of the dependencies that your software has into a really, really tiny shell, like a really tiny box, essentially. And it turns out that deploying these containers is really easy, and it lends itself really nicely to this thing called continuous delivery, which means if I don't want to just deliver my software once a month or once a week, even if I want to continuously update it and deploy it, these containers are perfect for that use case. And that's where I believe the majority of the world is moving to. So, forgetting about the infrastructure underlying those containers for a second, if you believe that containers are the way of the future, which I think is natural in the software industry, then you need an orchestration platform. You need something that will make all these containers work together at scale and scale up when you need them to and scale down when you need them to. And it turns out there was a big battle a few years ago about which container orchestration platform would win. And this open source project from Google, it's called Kubernetes. You look at read it, you may not see how to pronounce it, but it's actually a Greek word for navigator. So all of this is like nautical themed. Docker, by the way, is a nautical themed little tugboat as well.
No one's ever explained to me the Greek origins of the word Kubernetes before, so I really appreciate that
No
translation.
worries. We're here with useless facts, Patrick. Absolutely. We're here to support you on that. So you have this orchestration platform, and what runs under the covers is the traditional virtual machines or bare metal machine computers that clouds offer. So now you have this really beautiful layer of open source, and that's key, right? It's open. It's not owned by any single cloud provider. Layer of abstraction for you to deploy your software. The clouds like it and they don't like it. The industry is moving this way, so everyone's got to support Kubernetes. All three clouds and everyone else has a version of Kubernetes as a managed service that they support. They're all slightly different, but the semantics are the same. You deploy these containers, they run. When you don't need them anymore, they get destroyed. And the underlying infrastructure is what you really need to scale and manage. So that's kind of the premise. Now, if you believe that is kind of the way the world is going. And I believe over the next 5 to 7 years, everybody will be deploying their software this way. So it's a big bet on my part, right? Like if I'm wrong, there's no business, right? From my perspective. But if I'm right, then there's a massive opportunity. And here's the massive opportunity. You can now move away from these long-term reservations and start using shorter-term economic formulas in these clouds that will actually help you instead of hinder you for long-term lock-in. So turns out there are a few other models that clouds have. So if you were a cloud, Patrick, and you had excess, let's say you built out a region like Ashburn or California, Northern California, or Oregon, and you had a whole bunch of excess capacity in your data centers. Maybe you were only 20% full when you opened that data center. What would it be a mechanism for you to get some value out of those computers that are standing still and not doing anything? Let's just flip the equation for a second.
You rent them out, right? You rent them out to, yeah.
But you rent them out cheap because nobody so there's a huge discount implied with that excess inventory. So, while we think all of this is modern, kind of theory, we're always going back to the old retail adage of when you've got excess supply, it goes on sale. That's true in every industry, and it's true in the cloud too. So in the cloud, these things are called spot instances or preemptible instances. So what does that mean? That means that AWS or Google or other, if they have excess capacity in a region, they'll give it to you dirt cheap, 80% off, 90% off, 70% off. And the price fluctuates based on supply and demand economics, which is great. We want to see an open market, right? But here's the big caveat. Yeah, you get that computer, but if the cloud needs it for a real customer, in quotes, like someone who's going to pay full pop or a reservation, then they are going to yank it back from you. And they're going to yank it back from you within a couple minutes notice. So AWS is generous. They give 2 minutes notice. Google is not so generous. They give 30 seconds notice.
Oh my gosh.
So imagine you as a customer now on the other end of that equation. Okay, I could be really safe with these reservations. Cool. Or I can go into chaos with 2 minutes notice and none of my engineering team knows how to deal with the chaos. I'm not even gonna entertain those discounts. That's not for me. So only 7% of AWS customers end up using this, right? So there's a massive group of customers that believe this is just too much work and chaos for them to manage. And this is where we kind of step in and help with that problem. But imagine you could use that 90% off without committing to the future. Wouldn't that be a much better model? Like maybe you only needed a fraction of your reservations for the most sensitive workloads like databases. So maybe your reservations go from $100,000 to $10,000 or $5,000, and then you leverage this elastic pricing model for the rest of your stuff, which isn't as sensitive.